we're talking about math and specifically counting, and we've gotten this far without even talking about or looking at any of the numerals that you're used to seeing, these 1, 2, 3, 4, 5, 6, 7, 8, 9. In fact, I've tried to be as strict as possible in avoiding and urging you in your thinking to avoid duplicating what you already know, and try to think through yourself what kind of numbering system might you come up with. Now, it's helpful to do both. It's important to work through our own ideas and understanding and see how understand how things might have been developed, and see what ways you might have come up with it on your own if you had gone through the whole process your own. It's also important to connect your own rediscovery and reinvention ideas with what's out there, with what other people around the world are doing, with what people have been doing for hundreds of centuries, and to have a language of mathematics to be able to communicate with each other. So it's one thing for me to say, draw these symbols down here. I could draw this on a piece of paper, and I could know that this corresponds to one of my medium-sized two-handed packages, and this many, which is 7 of my small two-handed packages, and this many, which is 6 stray marbles left over, and know in my own symbolic shorthand notation what this means that I wrote down on a paper, so I can check my marbles from one day to the next to see if I've lost any. It's another thing what if I go on vacation and I leave you in charge of my marbles and you have to check? We need some system of understanding each other to communicate counting concepts, mathematical concepts, so that we can communicate with each other. And of course that becomes much more practical when we're exchanging money with each other and things like that. So we need some kind of common system of notation. We need a mathematical alphabet, and these numerals that we have provide that. This could be done a number of different ways, but the most populous human nations in the world today have all kind of agreed to a two-handed counting system. And at least the Western world, and many in the East as well, have agreed to use these symbols. These symbols that we use in the European world, we actually borrowed from Indo-Arabic roots. Centuries ago, the Indians and Arabs came up with these, and we borrowed it in the European context. As you know, if we've got just a single marble, then we draw this symbol and we say the word 1 in English. If we've got this many marbles, we draw this symbol and say the word 2 in English, and so on. This many marbles gets this symbol and the word 3 in English. 4, 5, 6, 7, 8. It starts to become apparent why these symbols are helpful. I mean, this many dots takes a few seconds to draw, whereas just this swirly 8 goes pretty fast, so that's pretty helpful. 9. Now say that I've got one more. What comes after 9? Well, you say 10. Okay, fair enough. In English, 10 comes after 9. But how are we going to represent that? Well, let's say that we have one marble for each finger and thumb on both of our hands. If we had to come up with a new symbol, what comes after 9? Well, it's not at all apparent. If we're working just with our dots for our marbles, then there's an obvious pattern here. From here to 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 here. There's a nice pattern that can be continued. But from here to here to here, to here to here to here, what's the pattern? Here, here, here. What pattern? What goes after this symbol? Should it be a smiley face? Should it be a frowny face? What looks like the number 10 to you? Should it be something like this? Something like this? Something like this? What should we draw for the number 10? If we had to come up with a new symbol for every new number as we go along, that would get extremely tedious. If we were going to try to express the number 1,000,000, we would need 1,000,000 different symbols. And that's going to get old. That's a lot harder coming up with 1,000,000 different symbols and remembering them all. That's a lot harder than just drawing 1,000,000 different dots. So we need something more systematic. Well, that's where our packaging system comes in. We're using a two-handed system. So these 9 numerals are enough. And then once we reach 10, we've filled up all of the fingers and thumb on both hands. So we package it together. We know that we've got one small package. And we actually know a little bit more than that, although it depends on how you think about it. We've got one small package, and then we've got nothing left over. This is where the numeral for 0 comes in quite handy. We use this symbol to represent nothing. It's actually kind of nice that it's kind of like a circle with empty space in it. You know, this 0 means what's inside there. It's like you're encircling nothing. If I want to draw nothing, how do you draw nothing? Well, draw a circle around nothing and say it's the stuff that's in there. What's inside of there? Nothing. So 0 is a nice symbol for nothing. This kind of circle or oval shape. So what we can do is, if we do have this many marbles, which we'd call 10 in English, we can package them together in a two-handed system into one small package of 10 marbles with nothing left over, and we can write that as one small package with nothing left over. Now, you all who know how to do math and know your numbers know that we don't actually draw this package for the symbol. We drop it, like I talked about. We thought about doing with our one-handed system. We didn't do it there, but we certainly can do it here, especially because we have this 0 here to tell us this is how many is left over after we do this many small packages of 10s. So one package of 10 with nothing left over, not just 10. If we have this many marbles and they package up like this, which is one small package of 10 with one stray one left over, we drop the packaging notation and we just write it like this, where we're all going to agree that when we write a 1 followed by another 1, that means one small package of 10, because we're using a base 10 system, a two-handed system with one left over. This many marbles gets packaged up like this, which is one package of 10, 2 left over, and we just decide to write this like this. And we've all come to an agreement that when we write a 1 and a 2, we do not mean that there's 2 packages of 10 and there's 1 left over. No, we mean it the other way around. We've just agreed that it means 1 package of 10 and 2 left over, or 2 left over when you've got after making 1 package of 10. We've all agreed that the package goes on this side, and then the leftover marbles go on this side. We can keep going, and if we have this many marbles, they package together nicely into this, which is two-handed packages, 2 packages where each package is a two-handed package, and nothing left over. And so we just write that as a 2 and a 0. And this packages up nicely into 2 small packages with a stray marble left over. And we'll just write that as a 2 and a 1. And we can see the difference between these guys. This means 1 stray marble after doing 2 small packages. This means 2 stray marbles after doing 1 small package. And we've just agreed that the number describing the packages goes on the left side here, and the number describing the stray marbles goes on the right side here. So I think you can continue on this pattern. In the next video we'll show some more examples with bigger numbers, but think through it for yourself. How is this system going to continue with larger package sizes?